Hi kids, we'll be going with this part 4 of Unit 1. You can look at the first question. The first question says, the circular scale of a screw gauge consists of 50 divisions and the linear distance travelled by screw in one complete rotation is 0.5 mm and it is equals to value of pitch scale division. Generally those two will be equal, but sometimes it will differ, but in this particular question they said it is equal. So the meaning is if you rotate one full circle, it will move by 0.5 mm and the distance between two lines on the main scale is 0.5 mm. When nothing is placed between the studs, 46th division of circular scale is coinciding with the index line. So generally 0 should be coinciding with 0, but 46th division is coinciding. The meaning is this 0 is somewhere above, 4 divisions above. So when you rotate 4 divisions this way, when you loosen 4 divisions, then 0 will be coinciding with 0. So what kind of error it is? When you place an object of length 4 circular scale divisions, it is going to show 0. So it is negative error, you need to add in the end. Anyway, that doesn't matter much. Yeah. So 46th division, generally 0 and 0 should be coinciding, but this 0 is above, 46th division is coinciding. 46, 47, 48, 49 and 0. 46, 47, 48, 49, 0. Now a thin plate of thickness 4.68 mm is inserted. 4.68. See, whenever you see 4.68, you will be seeing like how much times of integral multiples of 0.5 it is. That is 9, more than 9 times. So 9 times. So you need to rotate 9 full circles, then extra stuff based on what is that length. Yeah, so if you want to fit this much, how many rotations you need to do? How many rotations you need to do? Now 46th division is coinciding. See, actually, yeah, one circular scale division. What is going to be one circular scale division? That is for 50 divisions, it is going to move by 0.5 mm. So for one circular scale division, what is the reading? It is going to be 0.5 by 50 mm. That is 0.01 mm. 0.01 mm. So if you rotate this circular thing by one division, then the movement is going to be 0.01 mm. So if you rotate 9 full times, you will be getting 4.95. Sorry, 4.5. If you rotate 9 times, you will be getting 4.9 full circles, you will be getting 4.5, and apart from 4.5, extra is 14. Sorry, extra is 18. So you have to rotate 18 circular scale divisions. That is 9 full circles plus 18 extra circular scale divisions. 18 extra, so from 40, initially it was 46, so if I rotate 4, 46 was, 0 was here, so if I rotate 4 divisions, 0 will be coinciding. Then I will be rotating 14 more divisions, so totally 18 divisions. So basically I will be rotating 4 divisions, then 9 full circles and 14 divisions, so it will be showing 14 reading. I think the options were bad, but the minimum number of rotations are 9 rotations plus 18 circular scale divisions. Out of 18, 4 will go in the error, so remaining will be 14. If you don't understand what I speak, probably you can look into the screw gauge, understanding screw gauge video in your doubt clearance section, right? Or do by your own way, that's up to you. In a bicycle, the chain does not slip or stretch, that you people will be knowing. So it moves at the same tangential speed v on both the sprockets as shown in the figure. So this chain should be having same speed along the length of the chain. So from that equation, if this is the pedaling thing and this is the rear sprocket, this is front sprocket and rear sprocket, you will be pedaling, so this will be rotating and chain will be moving, moving chain will try to rotate this one. So basically the point the point on the sprocket here will be having speed r1 omega 1, the point on the sprocket will be having r2 omega 2, but there is no slipping between chain and the sprocket, so r1 omega 1 equals to r2 omega 2. So you can take the ratio also, that's up to you. Now the angular speed is inversely proportional to radius. Yes, you can see this relationship also holds for pulleys connected by a belt. Yes, that also you know, provided the belt that does not slip. For chain sprockets, the teeth must be equally spaced on the circumference of both sprockets for the chain to mesh properly with both. Yes, now the gap between two sprockets, two spikes here and two spikes here should be same, because the chain, in the chain there will be spacing, right? It should be fitting. So the distance between two consecutive spikes and consecutive spikes here should be same. That's what they were saying. Equally spaced on the circumference of both sprockets for the chain mesh to. Okay, let n1 and n2 be the number of teeth. So n1 here and n2 here. The condition that the tooth spacing is same on both sides is, yeah, you need to have the same spikes. So 2 pi r is the circumference and n1 are the number of teeth. So 2 pi r by n1 will be the distance between two consecutive ones. Similarly, here it is going to be the same thing. 2 pi r by n equals to 2 pi r by n. Now r1 by r2 is proportional equals to n2 n1 by n2. Now, yeah, you can see here r1 by r2 is omega 2 by omega 1. Here r1 by r2 is n1 by n2. So when you equate them, you will be getting omega 2 by omega 1 is n1 by n2. The angular speed of each sprocket is inversely proportional to the number of the teeth. So more the number of the teeth, less will be the angular speed. Yeah. On a multi-speed bike, you get the highest angular speed when omega 2 of the rear wheel for a given pedaling rate omega 1. Now, if omega 1 is the pedaling rate, for a fixed pedaling rate, if omega 2 has to be maximum, then n1 by n2 has to be maximum. n1 by n2 has to be maximum. This means that the largest radius of the front sprocket and the smallest radius of the rear sprocket, that is pedaling wheel should be of bigger radius and this sprocket has to be of bigger radius and this one has to be smaller radius, that you will be seeing in normal bicycle. Right, anyway, so going to the question, arrange the following in ascending order: speed of the bicycle with respect to ground, speed of the point on the rim of rear sprocket with respect to cycle, speed of the point on the rim of the front sprocket with respect to cyclist, speed of the chain with respect to the cyclist. Now, speed of this point and chain, everything will be same. So all these three will be same, but speed of the bicycle. Now, if you compare speed of the sprocket, speed of the circumference of the sprocket, it is going to be small r2 into omega 2, but speed of the bicycle wheel is going to be radius of the bicycle wheel into omega 2, assuming it is pure rolling generally. Yeah. So speed of the chain will be r2 into omega 2 will be less because radius of the wheel will be big, r into omega 2 will be more. So speed of the bicycle will be more. Speed of the bicycle with respect to ground will be more. Now going to the next part, what is the speed of the bicycle if man is pedaling at 1 revolution per second? So omega 1 is given as 1 revolution per second. You need to calculate what is the speed of the bicycle. So if you want to find speed of the bicycle, you should be knowing omega 2 because bicycle wheel is connected here. Yeah. So r into omega 2, where r is the radius of the wheel. Radius of the wheel was given 0.5 meters. Now you need to calculate omega 2. They have given omega 1. So you know speed of the chain should be same, r1 omega 1 equals to r2 omega 2. From there you can find omega 2 is 10 by 3 times of omega 1 because they have given r1 and r2. Omega was also given 1 revolution per second, that is 2 pi radians per second. Omega 1 is 2 pi. You can substitute this here, then you will be getting the required answer, speed of the bicycle. In which of the following combinations the bicycle moves with minimum speed? Minimum speed. Yeah, if it has to move with maximum speed, n1 by n2. Yeah, see. Speed depends on omega 2. More omega 2, more speed. So they are asking less speed for the same omega. So if omega 2 has to be minimum, then n1 by n2 has to be minimum. So from these options, you figure out which option has n1 by n2 minimum. That will be the required answer. Going to the next question. All the blocks are identical. Pulleys are light, strings are massless and inextensible. Each block of each mass is m. That is one case. Then other case is n plus 2 equal masses hang from a system of pulleys as shown in the figure. N is very large, can be considered to be tending into infinity. Mass of each block is m. So there are n blocks here and there are 2 blocks here. So totally n plus 2. Consider the system of pulleys shown in the figure. The string which is a loop with no ends. So there is a loop here and here it is like this. Here, yeah, the same thing if you, the similar thing when you make it in the form of a ring. But here symmetry is there, their symmetry is not exactly there. These two behave differently from this. Here everything is going to behave in the similar manner. N fixed pulleys and mass of each block is m. Now you can see symmetry here. So if you assume some block is going downwards, then the other block also should go downwards because there is no difference between these two properties. If you draw the free body diagram, you will understand. So same tension, because if this is T, this will be 2T. If this is T, this will be 2T. So there is 2T here, mg here, 2T here, mg here. So if this one goes down, this one also should go down. If this one goes up, this one also should go up. Suppose this goes down, then this one also should go down, this one also should go down. So everywhere it should be going down. That won't happen, because length of the string is fixed. If length of the string is fixed, then if someplace it is going down, someplace it should be going up. So acceleration here is going to be 0. That's a straightforward thing. Now going to this question, the options were bad, so I am not talking about the options. Anyway, I am going to attach the explanation from the book. You can read and you can understand what option matches. So suppose this acceleration is A upwards and this tension is T. This will be tension T. Now as this is massless pulley and this is ideal string, these two tensions should be same. It should be equal to half of this. Then only net force on the pulley will be 0. Now, yeah. Anyway, before going to talk about this, I am going to argue this tension by dimensions, it should be of the form mass into acceleration, and the mass factor is only m everywhere. So it should be a function of m. In specific, it should be linear function of m into acceleration due to gravity. Now, if acceleration due to gravity is becoming doubled, then if I do the same experiment in some other planet where acceleration due to gravity is twice, then this acceleration will be twice of whatever happened. That should make sense, because function of m, linear function of m won't change. It depends on the geometrical structure. Okay, so I am going to argue this tension is proportional to acceleration due to gravity g and some linear function of m. Now, if this is going upwards with A, this will be going downwards with A. So if I sit on this pulley, if I observe from this pulley, then effective force on this guy will be mg and ma. So effective gravity will be g minus a. Now, when I observe from this guy, it looks exactly like same structure, but instead of acceleration due to gravity mg, now it feels like g minus a, m into g minus a. So this tension will be proportional to the same linear factor, because geometrical structure will remain same, but it depends on, instead of g, it depends on g minus a, g effective. So tension depends on the g effective. It is proportional to g effective. So tension here depends on g, tension here depends on g minus a. So when I take the ratio, I will be getting acceleration is g by 2. I will be getting acceleration is g by 2. And there is other way of doing it, but for that we should be knowing some other basics. So if there is m1 and m2, yeah, if you draw free body diagram of this guy, and if you write down the stuff, you will be getting the tension. Tension here is 2m1 m2 by m1 plus m2 into g. Tension here will be 4m1 m2 by m1 plus m2 into g. The meaning is, if you want to replace this one with a single mass such that this guy don't know the difference, that is, he will be going to exert the same amount of force, which is 4m1 m2 by m1 plus m2 into g. What should be that mass? That mass is going to be 4m1 m2 by m1 plus m2. So whenever there is a pulley and these two masses, you can replace this structure with a single mass, which is 4m1 m2 by m1 plus m2. Let us call it as effective mass. So if I call this total mass as m, then this total mass also I can replace with m. If I can replace this total mass with m, this total mass also I can replace with some capital M, because it is infinitely extending, so it doesn't make any difference. The pattern is repeating again and again. But what we know, if this is small m and this is capital M, I can replace this pulley, this mass and this mass with a single mass whose mass is 4m1 m2 by m1 plus m2 into, m1 plus m2. I can replace this total thing with 4m1 m2 by m1 plus m2. But I know this total mass is going to be again equivalent to m. So when I solve it, I will be getting m is 3m. The other way of saying this, I can replace this thing with 3m. If I can replace this thing with 3m, then you can say 3mg here, mg here, net force is going to be like 2mg, driving force is going to be 2mg, mass is 4m, acceleration is going to be g by 2. Anyway, the explanation I am going to attach in the PDF, you can read it. Then going to the next question, now this is t and this is mg. If this is t, this will be t, so this will be 2t. So here t and mg, here 2t and mg. So we can expect here there is a t extra force in the upward direction when compared to this. So this will be going up and this will be going down, that we can easily assume. Now by symmetry, if this is going down with the acceleration here, this one also will go down with same acceleration here. Now I am assuming this is capital A. If this is capital A, this should be capital A, this should be capital A, because this is 2t minus mg, 2t minus mg. Force equation looks same, so acceleration should be same. Now if I write F equals to ma for this guy, it is mg minus t equals to ma. if I write f equals to ma for this guy, 2t minus mg equals to ma. But what is the constraint between them? If this one goes up by 1 meter, this one will go up by 1 meter, 1 meter, 1 meter. If this one goes up by 1 meter, this 1 meter and this 1 meter will disappear and come here. So if this one goes up by 1 meter, this one will go down by 2 meters. So if this one goes up by a, this one will go down by 2a. If this one, the length will decrease by, if this one goes up by 1 meter, then the length is going to decrease by 2 meter. If this one goes up by 1 meter, then the length is going to decrease by 2 meter. This decrement should be coming somewhere here, right? So if this one goes up, this one goes up. If this one goes up, the decrement in the length is going to be 2a, 2a, 2a. So if there are n masses, then the total decrement will be n into 2a, n into 2a. Now that will be, that will happen. This decrement here is going to be compensated by the increment here. So increment here will be a, increment here will be a. So this decrement, that is n into 2a, will be going as increment here plus increment here, which is 2a, a plus a. That's a constraint. Then we need to solve it. I am taking this equation, I am multiplying with 2. I am taking this equation where I am substituting capital A is small a by n. Now I am going to add them so that I can eliminate t. Then I will be getting acceleration as a function of g. Now when n tends to infinity, acceleration is going to be g by 2. This guy's acceleration is going to be g by 2. Yeah, when n tends to infinity, this is going to be g by 2, this is going to be 0, almost 0. So there will be very small movement here, but there will be some significant movement here. Anyway, you can read the explanation. I will be attaching the PDF, right? Thank you.